An equation the other day and I got x equals plus or minus square root of negative 4. Now in the real number system, square roots of negative numbers are undefined, so we've just kind of left it at that. But now it's time to introduce another number system that allows you to deal with square roots of negative numbers. That's called the complex number system. Complex numbers are combinations of real numbers, imaginary numbers, and complex numbers. So what are imaginary numbers? What are complex numbers? Imaginary numbers are square roots of negative numbers. So square root of negative 1 is defined to be I. This I indicates an imaginary part of a number. So for example, square root of negative 6 is the same thing as I square root 6. And this works out because square root of negative 6 is the same thing as square root of negative 1 times square root of 6. So the negative 1 becomes your I, and then you have I square root 6. And this square root of negative 6 is called an imaginary number. So what's a complex number? A complex number has a real part and an imaginary part. So for example, if you're solving an equation, you get x equals 3 plus or minus the square root of negative 6. This is actually two complex numbers together because it's 3 plus square root negative 6 and 3 minus square root negative 6. So if we're going to deal with these using complex numbers, it becomes x equals 3 plus or minus I square root of 6. So these are complex numbers. So what happens is you can do a two-dimensional graph. So you have a two-dimensional number line, if you will. You have the real part, which replaces the horizontal axis for where x used to be, and the imaginary part is vertical. So it's a two-dimensional number line now. And so the way it works is just like an xy graph. It's almost like 1 plus 4i here. The 1 is the replacement for the x coordinate, and the 4 is the replacement for the y coordinate. So when you graph this, you go right 1 and then up 4, and that's your 1 plus 4i. If you want to graph the square root of 2 on here, that's a real part only, and that's about 1.2, I think, roughly. Goes right there. And also, if you have a pure imaginary number, like negative 5i, that's just down 5. There's no real part, only the imaginary part. Now, complex numbers can be added, subtracted, and multiplied and divided. I'll just show you an addition example and a multiplication example. So here are two complex numbers, 1 minus I plus 3 plus 4i. And the way you add these is you just add the real parts and imaginary parts separately. You can't combine them. So you do 1 plus 3, which is 4, and then negative I, and then plus 4i is 3i. So 4 plus 3i. And if this were a subtraction, you would just be careful to distribute the negative sign, so it would be minus 3 and also negative I minus 4i. So you just need to be careful about that. Multiplying these, you just apply the FOIL method. So you do 1 times 3 first, which is 3, and then 1 times 4i, which is plus 4i, negative I times 3, which is negative 3i, negative I times plus 4i. Well, that one makes negative 4i squared, because I times I makes I squared. So it's almost like you're treating the I like a variable. It's really not, because it's indicating an imaginary number, but it behaves the same as a variable when you're doing algebra. So simplify 3, and then plus 4i minus 3i is plus I, just one I there. And this negative 4i squared, well, here's where it gets interesting. I squared is negative 1. So negative 4 times I squared equals negative 4 times negative 1 equals 4. So minus 4i squared is really the same as plus 4. And then you can simplify one more time. So you can simplify further. You can add the 3 and the 4 to make 7, and then you just have the plus I. Okay, so that's addition and multiplication. Now I want to talk about the idea of conjugates. Conjugates are numbers like this, and we actually have been dealing with them already just without talking about them as conjugates. Conjugate means you have two numbers like this. When you multiply them together, you just get a single real number. So I'll just show you what happens here. If you FOIL this out, 1 plus square root of 5 times 1 minus square root of 5. So you FOIL this out, 1 times 1 is 1. 1 times negative square root 5 is minus square root 5. And then square root of 5 times 1 is plus square root 5. And then square root of 5 times negative square root 5 is minus square root of 5 squared. Simplify further, 1 minus square root of 5 plus square root of 5, well that makes 0. So then you're left with 1 minus, and square root of 5 squared, well that's just 5 because it's square root 5 times square root 5, which makes square root 25. So that makes negative 4. So that's what happens when you have conjugates. You multiply them together, there's a square root involved, and there's a plus and a minus, and you get negative 4. So this is the result of typically solving using completing the square or the quadratic formula. You can call them conjugates. Complex conjugates work the same way. So if you have, say, 1 plus or minus 3i, these are conjugates. So if you FOIL them out, you do 1 plus 3i times 1 minus 3i. And 1 times 1 is 1. 1 times negative 3i is minus 3i. Plus 3i times 1 is plus 3i. And plus 3i times minus 3i is minus 9i squared. Simplify some more. The minus 3i plus 3i, those make 0. And then you're left with 1 minus 9i squared. And we said I squared is negative 1, so it's 1 minus 9 times negative 1, or 1 plus 9, which is 10. Okay, so complex conjugates multiply together to make only a real part, and they have a special rule where it's plus or minus something. So it's a real number plus or minus an imaginary part. Those are complex conjugates. And you'll learn more about those as you deal with solving equations later on.